Hello everyone. In last class, we just had the comparison between IIR and FIR filters. Now from today onwards, we'll be starting with their structures, or you can say the realization of filters, digital filters. In today's class, we'll especially be discussing realization of IR filters. Right. So there are 5 different methods or 5 different structures which are possible to realize these IR filters. Right. The first one is the direct form 1 realization, then it's direct form 2 realization, then we have cascade form realization, parallel form realization, and lattice ladder realization. So in today's class, we'll be discussing direct form 1 realization, right? And we'll take all of them one by one in next classes, upcoming classes. Okay. So the idea of direct form realization is quite simple, right? We know the equation, the difference equation we've already seen in the last class. So let us consider this system is a linear time invariant system, and obviously this is a recursive type system, okay, because of presence of this y of n minus k, right? It basically depends on the past values of your output, right? So this makes this system recursive one, okay, and obviously it depends on present and past values of input also. So this is the same equation. Now what we have to do is just expand these two summations. All right. Now first one here you can see this is the expansion of this one, right? And this I've expanded in here, right? This expansion is done actually by varying the values of these k, right? So for this summation will vary k from 1 to n, right? For k equal to 0, we'll consider a not equal to 0 only, right? So there is no significance in considering from 0, okay. But for xn, we'll consider k varying from 0 to capital M. All right. As you can see in this equation, if k is 0, so you get xn only, right? Likewise, if k is 1, you get xn minus 1. You are being shifted by 1 unit, right? Likewise, we have a shift of 2 units if k is 2, okay, and if k is m, we'll have a shift of m units. All right. Likewise, we can get these values, this shifted version of y, okay. Now we have two types of things in these equations you can notice. One is the input type of values and other one is the output type of values. So we'll draw structures for both separately and later we will combine this, okay. So for that purpose, we just consider this thing, these values of x to be w of n, right? And intermediate output we have considered. All right. Now this output wn will be having these values, right? xn, which is coming directly and multiplying with coefficient b naught, right? So if you see the first segment, first line here, you can see there's a coefficient b naught, and from here I'm getting xn, okay. This gets multiplied, and at this point we'll get xn multiplied with b naught. All right. And we know this thing we call it as delay, right? It's a delay element, unity delay, okay. It delays your signal by 1 unit, okay. So at this point what we get, x of n minus 1, all right, a delay of 1 unit. So x of 1 minus 1, n minus 1, sorry, will get multiplied with b1, right? So this value will get multiplied with b1, and at this point we get x n minus 1 multiply b1, right? Likewise, if you see at this point, we have already introduced one delay for this one. Now this second delay will introduce two times of delay, right? So at this point this delay will be n minus 2, okay. And you can see in the equation that x n minus 2 will get multiplied with b2, right? So at this point we are getting this thing, b2 multiply x n minus 2, right? At this point we already have b1 x n minus 1, x n minus 1, okay. And finally, as the equation is ranging up to capital M, right? This is capital M, sorry. So capital M, so this will be x n minus capital M multiply with this thing, right? So ultimately this delay will result in x of n minus capital M, okay. And at this point what we get bm multiply with x of n minus capital M. Okay, and we can also write this value also, that is one value just before the final value, right? So this delay will be x of n minus, this delay is m minus 1, right? So this becomes m plus 1, right? And here you get x of b m minus 1 multiply with x n minus m plus 1. All right, and if you see this equation, so you can observe that all these values will get added up, right, and will result Wn. So Wn is the output of this stage. Okay, so we'll put summations here, right, so that all these values will get added up and will result Wn. So we have this output. Now this is being fed to another system which is having yn and delay elements of yn, right? As you can see in this equation, this is the equation of yn, right? This was your yn, shifted version of yn, or past values of y, right? And this was the shifted version of x, or present value of x is also included in between. So we'll write wn in place of all those things, okay, because we have already drawn that thing. Okay, so this wn is fed to this side, okay, and this will get added up with all the delays of y, right? These delays are actually introduced due to feedback. Okay, so you can see here's my output yn. So at this point I'll consider this as yn, right? Now this is again same delay element, right? It will delay my output by 1 unit, and I'll get here yn minus 1. Okay, and this yn minus 1 will get multiplied with minus of a1, as you can see. Okay, it will get multiplied with minus of a1, and at this point we get this thing, minus a1 multiply yn minus 1. Okay, the same way we'll introduce another delay, so this becomes yn minus 2. Okay, and this will get multiplied with minus a2, and at this point we'll get this thing. Okay, in similar way at this point we'll be having this delay y of n minus, because this is 1 unit before the final value, right? So y of n minus capital N plus 1. All right, and this will get multiplied with this thing, right, and will get added up with all those values. And finally at this point we'll have y of n minus capital N, right, and it will get multiplied with this, and we'll have at this point minus an multiply with y n minus capital N. Okay, and as you can see in this equation, all these values, all this shifted version of y are adding up and with w of n, right, and w of n we are getting from this side. So these all values will get added up, and this sum will result y of n. Okay, now we have drawn the structures for input and output sections both. Okay, but our job is not done yet. Okay, now we have to combine these two. Okay, this way we can combine these two sections, right? This was my xn or delayed version of xn at this side, and yn and delayed version of yns on this side. Okay, wn was the output or intermediate output of xn, right, and this will act as input to yn, right? So ultimately this is my direct form 1 structure type. Okay, so this is how you can realize using direct form 1. That is all for now. Thank you. See you in next lecture.